We're continuing to look at some of those foundational skills that we'll need for algebra, including this idea. So a variable is when we just replace something with I don't know. Okay, so suppose I wanted to multiply 3 times 6. I know that's 18. Well, suppose someone told me they didn't know what that number is. I introduce a variable, an I don't know, into it. And what algebra is all about is we're going to solve for those I don't knows. Now, a constant is as simple as this. Constant is simply a number. He doesn't change, but a variable could be lots of different numbers, could be a single number. So this one's changing. We don't know what it is, but a constant always stays the same. Let me see what we're doing here. I'm not sure where we're going with this yet. Hold on. Yeah, let's just dive in. We'll deal with this stuff in a second. Now, if you have an inequality sign, it always reads from left to right. So we've got two choices here. One of these is greater than and less than, so how do we remember? One trick is the alligator's mouth eats the larger number. But the way I like to think of it is we go left to right, and these signs read left to right. And it'll always start with what you're facing. So this is the lesser than side because it's the smaller point. So less than, and we kind of don't finish it. Less than the other side. Now we're reading left to right. We come to this one. This is obviously the larger side, so the greater than the other side. So this is less than, and this is greater as we read it going left to right. So as we're talking through here, let's see if they're true. Is 17 less than, so we're going left to right, is it less than or equal to 26? Okay, it just wants us to put it into English. I thought it was going to ask us if this was true. Yeah, it is. So this reads 17 is less than or equal to 26. B here we've got 8 is not equal to 17 minus 3. We're just going one word at a time as we work from left to right. So I've got 12 is greater than, as we go from left to right, greater than 27 divided by 3. And then y plus 7 is less than, we're going left to right, 19. Okay, so we're going left to right. We read this way, we're going to write this way, do our math this way. 14 is less than, now it's also got an equal sign, or equal to 27. Okay, 19 minus 2, I'm working my way left to right, is not equal to 8. 12 is greater than, so left to right, that's the larger side, greater than 4 divided by 2. And lastly, x minus 7, so I'm going this way, this is the smaller side, less than 1. Okay, give a few more here. I don't know if you need it, but we'll do it anyway. 19 is greater than or equal to 15. 7 is equal to, just working left to right, 12 minus 5. 15 divided, going one step at a time, by 3 is less than 8. Y plus 3 is greater than 6. So greater than because we're going left to right, big end is there. Okay, now what we're going to do next is to remember the order of operations. So I think it's time. Please excuse my dear Aunt Sally. So parentheses really means grouping symbols. So here's what we got. Parentheses, exponents, multiply, divide, and addition and subtraction. So the way you remember the order is, please excuse my dear Aunt Sally. Now parentheses really means any kind of grouping symbol needs to be done first. Exponents come next. Then multiplication and division are technically tied. And so if there's a tie, we've got both of them going on. We're going to work from our left to our right. And lastly, we've got addition and subtraction. In that case too, if those are actually tied, and we'll move left to right. Okay, so I think that's where we're going with this. So an expression is any time you don't have an equal sign. So we have an expression here because we're not equaling. We can't solve this. This is one of the common mistakes. People often try to solve for an expression. It doesn't have an equal, so we aren't going to be able to solve it. An equation, then, it does have an equal sign. If I add an equals 9 here, this is an equation. It can be solved. Okay, so first here they're just asking us if it's an expression or an equation. So A has an equal sign, so it's an equation. B is just an expression. There's no equal sign. There's no equal sign in C. There is in D. Okay, so I've got an equal, so this is an equation. There's no equal in B, just an expression. Okay, again, expression, equation. Okay, I think we're going to go to the order of operations. So the base is, if you were taking something to an exponent, the base is the number that you're taking to the power, and that's the exponent. So the base down here, exponent up there. So 7 to the second power, 5 to the third power, 9 to the fourth, 12 to the fifth. Okay, so we're taking 3 to the fourth power. That just means 3 times itself 4 times. Crunch that down, we get 81. So 5 to the third, 5 times 5 times 5 is what that would mean. So I've got 25 times 5, it's going to give me 125. Now 1 to the 7th means 7 ones. But 1 times itself just keeps getting me 1 over and over again, so that's just going to be 1. Okay, 7 squared, 7 times 7. 49. Now they're trying to trick us here. We've got 5 zeros being multiplied, but that doesn't do anything. It's still just 0. Okay, well I thought order of operations was coming. Maybe that's coming later, or that's possibly the next video. But so we're going to work, so much about math is to try to put the real world into math language. And so we're going to work as a translator, translating between English and math, and sometimes the other way around. So we want to translate each of these into the math language, and we're going to go one step at a time. The difference tells me I'm subtracting, but it's the difference of 17x and 5. So, okay, what am I subtracting? I'm subtracting these two. Okay, the quotient tells me division. So normally that means this. Well, we could write it two ways. But what are we doing the quotient of? 10x squared and 7. Now in algebra, a lot of times we're going to show a quotient is the same thing as a fraction bar, but at this point I would take either of these. Okay, let's translate. Difference. Okay, well, what is the difference of? It's the difference of 14x squared and 13. The quotient, that's the division, so I'm going to draw that. 12x and 2. So you could also have written that as 12x over 2. All right, the sum of. So sum is addition. What am I summing? Those two. The product of 7 and y. So I should have talked you through that a moment. Product is multiplication. Now in algebra, because we use x's so much, we're going to put multiplication as a single dot. So it's the product of what? 7 and y. Now a very common thing in algebra is we'll stop showing that. If these two are sitting next to each other as variable, a number by a variable, we assume the dot is there. So these two things are really saying the same thing. Okay, 17 more than y. So I guess I should keep doing this. More than is addition. Now, more than, it makes us go the other way around. We don't see less than makes us go the other way around too. So that's where they're getting at here. We don't usually use more than in algebra very often, but 17 more than y is going to flip it around. And 9 less than. So less than is subtraction. And normally we'd go right across. We'd go 9 less than 9x squared. But less than makes you flip it. So there's only a few of these that you got to watch out for, and they're both here on this one. So technically this reads 17 more than y. And you could do that, but more than really flips it around as well. So what I'm getting at is these are the two. Be cautious. It doesn't change anything with addition, but it definitely does with less than. If you write this the other way around, that is not the same thing. Okay, so we have 11 more than x. That's okay. It's really kind of meant to be flipped around, but it won't. These two would get you the same answer. But 14 less than 11a, that will not. Less than makes you flip it. You're taking it away from 11a. Okay, 13 more than z, you'd get this. And 18 less than 8x. Get you that. Okay, now we've got some tricky ones here that are really important. Like, we're going to be building a lot of these equations later. We're going to go one word at a time. I've got 5 times. So that's multiplication. Okay, so I'm thinking this. But what's different about this here is we're timesing this entire group. We're timesing the sum of m and n. Okay, so 5 times the sum of those two. Well, if we're going to multiply by a group, we need a grouping symbol. So I am multiplying this entire group, the answer between the sum of m and n, so I need a parentheses. Now, you could show the dot, but if it's sitting next to each other in algebra, this means multiplication. So I'd have 5 times the sum of these guys. Okay, now this is why they're doing this. Now we're going to do the sum of, that's addition. Now it's 5 times m and n. So they've tricked us here. This time the things we're summing are 5 times m and n. That's different. This one needed a grouping symbol because we're multiplying by the sum. This one we're summing together 5 times m and n. So a little clever wordage there. So if you look at A, I've got 4 times the sum. So this is the group. I'm going to multiply the sum of these by something. So I need a grouping symbol. And the sum of 4, so I've got a sum. Let me go back up here. I've got a sum. And what's that sum of? 4 times P and Q. Okay, the difference of 2 times x and 8. So difference. Okay, what is it the difference of? 2 times x and 8. Now they're doing the grouping symbol idea again here, I think. 2 times the difference of x minus 8. So I'm going to multiply by 2 the difference of x minus 8. I have to finish this first, and then I'll multiply it by 2. So I need a grouping symbol. 2 times what? This whole group of the difference of x and 8. Okay, so I think order of operations is coming. There wasn't a lot of that there. We wound up doing mostly some basic core ideas about an expression does not have an equal sign, an equation does. And we also took a look there, again, we looked at exponents as well, and then we did some basic translating, being really particular to be careful of if you're ever needing to use a grouping symbol.